Welcome. Let's work Algebra 2 Homework 5.4. So you just learned about the factor theorem, which, to summarize what we just learned, I might say that x minus a is a factor of a polynomial p if and only if p of... I did that again. I did that in the notes too. P of x is equal to 0 when you plug in a. Okay. So, and that we can also use synthetic substitution to evaluate a polynomial. Those were kind of the two things that we learned. So we're going to determine whether x minus 8 is a factor of x to the 5 minus 8x to the 4 plus 8x minus 64. So what we're going to do is we're going to set up for synthetic substitution and test to see if, we plug 8 into this polynomial, we're going to get 0. So I'm going to kind of copy my coefficients, 1x to the 5, negative 8x to the 4, no x to the 3's, no x to the 2, so I put in a 0 for each of those, 8x and negative 64. Okay, and I'm going to divide that by x minus 8, so I'm running 8 through right here. Okay, so I'm dropping this down, that's going to be 1, multiply, add, multiply, add, multiply, add. Okay, this is fortunate. Multiply again, 0 times 8 is still 0. Add, now I'm finally getting something that's not 0. Okay, and now I'm going to multiply, add, and since I get a remainder of 0, okay, I know that p of 8 is 0 if p of x is x to the 5 minus 8x to the 4 plus 8x minus 64, so I can say that yes, it is a factor. Okay. And then we've got another one where we're going to determine if this binomial is a factor, and so we're going to again set up for synthetic division. So we're going to say, all right, 3x to the 3, 28x to the 2, 29x, and 140. That's some interesting coefficients, but I have a feeling it's going to work out just right. Okay, so over here I've got x plus 7, so I'm going to check negative 7. I'm going to run this through synthetic substitution, and I'm going to drop down the number, multiply, add. Okay, so I've got 28 minus 21 is 7, and 7 times negative 7 would be negative 49. Add these together, I'm going to get negative 20. Oh, this is tricky, yeah. So if I multiply negative 20 times negative 7, I'm going to get positive 140. I add those together, and I'm going to get 280. So if you made like a sign error or something like that, you could be tricked into thinking that, it had a remainder of 0, or if you forgot and subtracted these, you could get remainder 0 and say yes. But since this remainder is non-zero, I know that this is not a factor. I think we determined that was negative 49. I'm not sure where it went, but there you go. Okay, number 3, use the factor theorem to verify that each linear binomial is a factor of the given polynomial. Okay, then we're going to just find the other factors if possible. Okay. Which I have a feeling is going to be possible. So I'm going to go over here and I'm going to say, all right, the first factor is x plus 3. Okay, now I'm looking at this thing and I'm saying that I can already factor this with group and factor. But if you don't want to factor it with group and factor, no big deal. I'm going to use synthetic substitution since that's kind of like the new flavor of the day. So I'm copying in the coefficients, 1x to the 4, 3x to the 3, 0x's, negative 1x, and negative 3. And I'm going to run negative 3 through synthetic substitution. So drop it down, multiply, add, multiply, add, multiply, add, multiply, add. Okay, great. Got no remainder, so that means that it was a factor. And so what I'm left with, I have that x plus 3, and the other factor is going to be, kind of the quotient here. So this is negative 1, no x's, no x squareds, positive 1x to the 3. Okay, and so I see it's a difference of 2 cubes. I can factor that. So x plus 3, I see that this is the cube of x and the cube of 1. Okay, so I know I need x squared, 1 times x, and 1 squared. Okay, and so, if it's x minus 1, it's the same sign, opposite sign, always positive. Okay, and that's fully factored there. Okay. Oh, the next one is x plus 3. Okay, so we're going to need to set up for synthetic substitution. So I'll say 2x to the 4, negative 9x to the 3, positive 7x to the 2, negative 14x, and positive 8. divided by x plus 3. So drop it down, multiply, add. Huh. I feel like I may have copied something wrong here. Okay, I'm going to keep going. I'm going to have faith, but 15 times 3 is 45. Plus 3. Yeah, I feel like it must have been supposed to be x minus 3 or something. But I guess I'll just keep going. 52, work it as it's written. 52 times negative 3 is 100, negative 156. I mean, it's obviously not getting any better, it's just getting worse. Negative 14, and that would be negative 160. This would be positive 480, and I got 488. Okay, I'm going to pause for a second and see what's going on here. All right, I think I copied the factor wrong because it looks like it should be x minus 4. Okay, so I guess as the thing was written, you're going to say, hey, this thing isn't factorable because x plus 3 is not a factor because I didn't get a remainder of 0 when I did synthetic division, or when I substituted, I didn't get that p of negative 3 was equal to 0. So I'm going to run 4 through synthetic division because that'll be just right. And I'll drop this down, multiply, add, multiply, add, multiply, add, multiply, and add. Okay, so that would be 0. So I've got x minus 4 multiplied by, oh boy, so a negative 2, a positive 3x, a negative x squared, and a 2x to the 3. At this point, this is not group and factorable. We don't see that parallelism from 2 to negative 1 as 3 to negative 2. So we're not going to be able to do anything, right? We don't have any other factoring techniques at this point. Maybe later there will be something else we could do to maybe see if this thing is further factorable. I'm not sure. I'm not. Let me think. Nah, I don't think there's really anything else we can do with this thing. I must have typed something wrong in when I made this polynomial, because I know I wanted something to happen here. I'm sure I wanted it to divide down and be group and factorable, but I must have copied a number wrong. So pardon me, but this was, still something we could do. All right, now we've got a geometry problem. So we got the volume of the rectangular prism is given by 2x to the 3 plus 17x to the 2 plus 46x plus 40. Find an expression for the missing dimension. Okay, I mean, I would think that it's probably going to be... Oh, I actually don't know what it's going to be because that 2x to the 3. So yeah, let's just find out. So what we're going to do is we're going to set up for synthetic division. Right, we're going to divide v by x plus 2 and then by x plus 4. So I've got 2x to the 3, 17x to the 2, 46x, and 40. I'm going to divide by x plus 2, so I'm going to run negative 2 through synthetic division. So 2 multiply, add, multiply, add. Positive 20, multiply, add. All right. So now I've got something here that I can then continue to run synthetic division on, because, I see it's going to be 2x squared plus 13x plus 20, and I'm pretty sure I can factor that. But if they're saying x plus 4 is a factor, then I'm not sure if they mean it's a factor, but because, what if this question mark side length was, had a remainder? That would be possible. So I'm going to just run through synthetic division. Not totally sure what's going to happen, but yeah, it is going to give me another factor. So I know that this is going to be 2x plus 5 here. And I also know that x plus 2 and x plus 4 are side lengths of this prism. And there we go. And if you wanted to check to make sure this worked, you could distribute it out and combine the like terms and see that it's going to give you that expression for v in terms of x. All right. Number 6, what's the value of k where x minus 7 is a factor of h of x? So we're going to go over here, enlarge that a little bit, and set up for synthetic division, okay, or synthetic substitution, because if it's a factor, I can run it through synthetic, and I'll get remainder 0. So 2x to the 3, negative 13x to the 2, negative kx, and positive 105. We're going to run 7 through there. So drop it down, multiply, add, multiply. Okay, so if I add negative k plus 7, I can just have negative k plus 7 or 7 minus k. I should have done that right, yeah. And then now I'm going to have to multiply 7 by negative k plus 7. And so I'll have negative 7k plus 49. Now if I was adding 50 to 105, I'd get 155. So I should get 154. So negative 7k plus 154. And if it's going to be a factor, then this number here that I'm about to hit with yellow highlighter, it's got to be 0. So I set up an equation I can solve over here. Negative 7k plus 154 is equal to 0. Okay. All right, maybe I divide both sides by negative 1 to make me a little more able to think about this. Now, if you have to go to a calculator for 154 divided by 7, no shame in that. Okay, I'm seeing what it is now. But if you're still not seeing, think about a number that's nearby 150 that's divisible by 7. Okay, we know 7 times 2 is 14, so 140 has to be divisible by 7. What you can do is you can say, hey, that's 140, and then how much do I have left? Okay, 14. And then if I divide both sides by 7, I just have to remember to divide everything by 7. So 140 divided by 7 would be 20, plus 14 divided by 7 is 2. And that's where I would get k is 22. Okay. And now we're going to consider this polynomial. We've got, a quadratic factor of p. Cool. Okay. Yeah, I like this problem type. So, I already forgot, it's x squared minus 1. Okay, so x squared minus 1, we know how to factor that. That's a difference of 2 squares. So x plus 1 times x minus 1. Okay. And then I'm going to say, okay, I can run positive 1 or negative 1 through synthetic division. I think eventually I'm going to run both of them through to knock this 5th degree down to a 3rd degree, and I bet then I'll be able to do group and factor. Hopefully I copied this problem right. So 1, 2, negative 5, negative 10, positive 4, positive 8. I should check to make sure I don't have any missing powers of x. I don't. Okay, all's well here. I'm going to run this through synthetic division. So I'm going to divide by x minus 1 first. Maybe I'll just use positive 1. Drop it down, multiply, add, multiply, add, multiply. Ooh, yeah, that's going to be all right. Add, multiply, add, multiply, add, and okay, we've got ourselves clean division. Okay, so x minus 1 was a factor. Now we're going to go through synthetic division again. This time we're going to divide by the x plus 1. So I'm going to run negative 1 through here. Multiply, add, multiply, add, multiply, add, multiply, add. Okay, I've got another clean division, and I'm thinking this one's going to be able to group and factor. So what I've got now is I've got x plus 1 times x minus 1 multiplied by whatever I've got left here in highlighter. So that's going to be negative 8, negative 4x, 2x squared, and a positive x to the 3. Okay. And that is itself going to be factorable. I can take the first 2 terms and say, what do I got common to them? So we have just an x squared. I'll be left with an x plus 2. And then negative 4x minus 8, I can factor out negative 4. No. Can I? Oh, yeah, okay, when I factored it out, I was looking too far ahead. Over here, x squared, that'll be times x plus 2. Negative 4 times, again, x plus 2. Okay, this stuff isn't going to change, but over here I can factor out an x plus 2. I'll be left with an x squared minus 4. Okay, and that itself can be further factored. And so then I might go out here and say my final solution is going to be p of x equals x plus 1 times x minus 1. Multiplied by x plus 2, multiplied by x squared minus 4, which is x plus 2, x minus 2, so I guess I could just say there's a second power of x plus 2, and then an x minus 2. Okay, that's it for, yeah, that's the whole homework, right? All right, so that's going to be all for this video. Thanks for watching.